The Symphony of Emergence, a tale of nature and technology. In a small village surrounded by lush green forests and cascading hills, there lived a curious girl named Mira. From a young age, Mira had a knack for observing the world around her with extraordinary attention to detail. She was captivated by the way ants created intricate tunnels, how birds moved in mesmerizing flocks, and how trees in the forest seemed to stand in silent, harmonious communication. Little did she know, these childhood fascinations would lead her on a journey to unravel one of the most profound principles of existence: emergence. A childhood fascination. Mira's curiosity was first sparked during a summer evening when she witnessed a flock of starlings in the sky. The birds formed shifting patterns that danced across the twilight like a living painting. As they moved, the shapes morphed seamlessly from one to another, evoking both mystery and awe. "How do they know where to go?" she asked her father. "They follow simple rules," he replied, "but together, they create something extraordinary." Those words stayed with Mira, embedding themselves in her mind like seeds waiting to sprout. The journey of discovery. As Mira grew older, she pursued studies in biology and computer science, determined to uncover the secret behind the collective intelligence she had marveled at as a child. At university, she came across the term emergence, which described how simple components could interact to create complex systems. From ant colonies to human societies, emergence was the invisible thread connecting life's most intricate patterns. Her first project was to model ant behavior using computer simulations. She learned that ants followed 3 basic rules. Leave pheromone trails when food is found. Follow the strongest trail. Avoid obstacles. By programming these rules into her computer, Mira watched as virtual ants mimicked the efficiency of real colonies, finding the shortest path to food sources. "It's incredible," she thought, "how such simplicity can lead to such complexity." Nature's hidden network. One summer, Mira decided to explore a vast, ancient forest near her village. She met Dr. Arjun, an ecologist studying the wood wide web, a subterranean network of fungal mycelium connecting the roots of trees. This network, Dr. Arjun explained, allows trees to share nutrients and information. When one tree is sick, others send it resources. It's a cooperative system that keeps the forest alive. Mira was amazed. Beneath the forest floor lay a communication network more intricate than any human invention. Inspired, she began researching how the principles of the wood wide web could be applied to technology. Technology inspired by nature. Mira's journey led her to the field of artificial intelligence. She attended a lecture by Dr. Kavya, a pioneer in neural networks. Artificial neural networks, Dr. Kavya explained, are inspired by the brain. Each neuron on its own is simple, but when interconnected, they can recognize faces, translate languages, and even create art. This is emergence in action. Mira saw parallels between neural networks and the wood wide web. Both systems relied on decentralized interactions to produce remarkable outcomes. Fueled by this connection, she worked on a project to design smart cities. Instead of rigidly planning every detail, Mira proposed creating systems that encourage spontaneous organization. By equipping neighborhoods with sensors to share energy usage, waste levels, and traffic patterns, cities could adapt dynamically to the needs of their residents. The Symphony of Starlings. Years later, Mira returned to her village, now a scientist recognized for her groundbreaking work in emergence. One evening, she sat by the same meadow where she had first watched the starlings. This time, she understood the science behind their beauty. Each bird followed simple rules: stay close but not too close, match the speed of neighbors, and avoid predators. These rules created the stunning murmuration she had seen as a child. Watching the flock, she realized something profound. The principles of emergence weren't just confined to nature or technology. They were a blueprint for harmony, a guide to creating systems that were resilient, adaptive, and beautiful. A vision for the future. Mira's work culminated in the creation of a global initiative called the Emergence Project. The project aimed to solve pressing global challenges using emergent principles. In one experiment, Farmers in drought-prone areas were connected through an AI-driven network. Sensors in the fields monitored soil moisture, crop health, and weather patterns. Farmers shared this data, allowing the community to collectively manage resources. The system mirrored the cooperation of the Wood Wide Web, leading to higher crop yields and reduced water usage. Another initiative focused on education. Using AI, students were matched with peers and mentors based on their strengths and interests, creating a dynamic learning environment that evolved with the students' needs. The legacy of emergence. Myra's work inspired a new generation of thinkers. Her discoveries showed that emergence was not just a scientific concept, but a way of life. It demonstrated how small actions, when connected, could create profound change. Years later, as Myra walked through a vibrant, self-sustaining city she had helped design, she paused beneath a mural of starlings in flight. Beneath it, a plaque read, "The whole is greater than the sum of its parts." Smiling, Myra reflected on her journey. From the murmuration of starlings to the interconnected networks of trees and technology, emergence had been the hidden force shaping her life and the world around her. Through the lens of emergence, she had learned that the answers to humanity's greatest challenges lay not in controlling complexity, but in embracing it. Together, like the starlings in the sky, humanity could create a symphony of harmony and innovation.